Hello everyone. In this video, we'll verify circular frequency shift property of DFT. And the statement says that if there is a shift in frequency domain, in time domain, x of n gets multiplied with the sequence e power j 2 pi by n into m, where n is the number of point. In our case, it is 4, and n takes a value starting from 0 to number of point minus 1. In the sense 0 to n minus 1. In our case, 0 to 3. And m is the number of shift corresponds to frequency, this m. Okay. Let us take an example. Say x of n is 1, 2, 3, 4. If I take its DFT, which is 4 point here, x of k ends up with 10 minus 2 plus 2j minus 2 and minus 2 minus 2j. If I assume m as 2, in the sense x of k shifted right 2 times, circularly shifted right 2 times. We verify this left hand side first. What does the left hand side says? X of n gets multiplied with this sequence. In this case, n is 4, so 2 pi by 4, n into m, and since m we have assumed at 2, n times 2. So this is equal to x of n. X of n is this sequence, which is 1, 2, 3, 4, is multiplied with e power j. So 2 times 2 is 4, 4, 4 cancels out. We end up with e power j pi n. And since e power j pi is minus 1, I can write e power j pi n as minus 1 power n. And if we multiply these two, where n takes a value starting from 0 to 3, if n equal to 0, minus 1 power 0 is 1, 1 times 1 is 1. If n equal to 1, minus 1 power 1 is minus 1, 2 times minus 1 is minus 2, and so on. Basically, for even values of n, we get positive. For odd values of n, we get negative. Now, if I take 4-point DFT of this sequence, we end up with minus 2, minus 2, minus 2j, 10, and minus 2 plus 2j. The thing is, no, this sequence is nothing but our original sequence x of k, which is circularly shifted right 2 times, which is nothing but x of k minus 2 mod 4. So if I shift this right 2 times, minus 2 plus 2j comes here, 10 comes to this place, minus 2 minus 2j comes to this place, and minus 2 comes to this place. So this is what's happening in frequency domain. So we showed if there is a shift in frequency domain, in time domain, x of n gets multiplied with this sequence e power j 2 pi by n nm. Now we shall verify this in Scilab. To verify circular frequency shift property of DFT. PLC clear close. X is equal to, we shall read the input sequence, input, enter the sequence x of n. Also, we shall read the shift, enter number of shift. Now in our statement, we have n and m. N actually, its sequence takes starting from 0 to length of this x of n minus 1. So we shall define that also. N start from 0 to length of x minus 1. And also this n is nothing but length of x. This n is nothing but whatever the length of x we give, that will go to n. Right now, what we shall do is, we'll multiply x of n with this sequence. We'll put it in W. So W is equal to exp e power percentage I 2 into percentage pi by n. N is defined, n is nothing but length of x, and inside this into n into m. So where is this? Into n into m. E power j 2 pi by n into m. E power j 2 pi by n into m. Okay. Now the left hand side is nothing but, if I take or multiply x of n sequence with this sequence, which is nothing but x. When I say multiply, it is element by element, so for dot star into W. Now, since I multiplied these two, now I'll directly take DFT in that line only. So DFT of this, which is nothing but FFT of, in our case, which is FFT of this. Now we'll display of LHS. Now LHS should contain time shifted version of this frequency domain sequence. We'll verify that. So frequency shift property. Go back to console window. Enter the sequence 1, 2, 3, 4. Enter number of shift 2. So this is multiplied with 2. Okay. So consider this as 0, as I told you in the previous video, and consider this as well as 0. So we end up with minus 2, minus 2, minus 2j, 10, minus 2 plus 2j. So minus 2, minus 2, minus 2j, 10, minus 2 plus 2j. Thank you.